Hi, everyone. Welcome to this month's meeting of the Nashville Microsoft Azure Users Group. I think I'll turn off my video so that we get good bandwidth here. Anyway, as you know, this is the Nashville Microsoft Azure User Group. That's our website address on the screen there. The session's being recorded, and we have a YouTube channel. So if you have to leave before it's over, or if you have someone who you want to have look at the meeting afterwards, feel free. It's up there. Okay. Okay. Some of you are new. A lot of you are not new, but this is about the group. We're here. We're all about Microsoft Azure. It's educational. It's the ability to network with your peers, and we cover things at all levels. We cover both infrastructure-focused and developer-focused topics. We try to mix it up a fair amount. If you, as I said earlier, before we started recording, if you have a suggestion for a future topic, let us know. Okay, but we really want to provide a forum for open discussion and networking. The group normally meets every third Thursday of the month at Microsoft. Obviously, with the pandemic going on, we don't do that anymore. So we don't have food and networking because we do a little networking before the meeting. In fact, or we can do it after I finish and before our main presenter talks. But we're kind of flexible. We're trying out different formats. Anyway, we're only meeting online for the near future. We'll see how things go, later in the year or early next year. We have over 1,600 registered members, and the number's growing up all the time. So that being said, tell everybody that you know that might be interested in the group about the group, because we could always use more coworkers, more fellow people who are interested in Azure. And like I said, let us know about the topics you're interested in. We've got a board of directors. I'm the original founder of the group. I founded it back in 2013 with 4 people. Now, obviously we have over 1,600. I'm the founder and the president. By day, I'm a cloud solution architect with a company called RedApt, a big consulting firm. Roger Dahlman works for Deloitte. He's an enterprise architect for them, and was a co-founder with me, and he's vice president of the group. Tim Warner is a name that many of you might recognize. Tim is a Pluralsight author and a Microsoft Azure MVP that's fairly well known in the industry. And Tim is on our board. Tim is also providing us with this team subscription that we're using to be able to do the meeting this way. Okayla Allred is another board member, and she's our director of academic outreach. She works with the colleges and universities in the Nashville area to bring new members in at that level. Excuse me. Matthew Puckett is our permanent Microsoft meeting space sponsor. He's been our sponsor since 2013, and he's a Microsoft Principal National Cloud Solution Architect. Shout out to Jack Hagler from Vaco, who's our permanent refreshment sponsor. Again, he's been our refreshment sponsor for the last 7 years, since 2013. Jack is a Vaco Technology Associate Director of Recruiting. Already thanked our sponsors, but just to repeat, Microsoft's the meeting space sponsor. Vaco's our refreshment sponsor. Tim is providing us with the team subscription, and my company lets me spend time during the day working on my group if I have to. So that's good. Let's see. We are working on having a sponsorship program. We'd like to start, even when we're having online meetings, we'd like to start giving stuff away to the attendees and possibly having raffles of gift certificates and things like that. So if your company wants to become a sponsor of a future meeting in exchange for a 10 or 15-minute slot at the beginning to talk about their company, get in touch with Roger Dahlman. He's going to be in charge of our sponsorship program. We've got some meetings upcoming. In fact, this is a first for us. We've never had this many meetings in advance lined up. And that's a good thing and a bad thing. It's a good thing because we know where we're going to be in the next few months, but Azure changes so frequently, sometimes we want to slip in a new topic or talk on short notice. So we'll see how this goes when we have this, this much of a backlog of meetings. Anyway, October 15th is going to be on security and securing your Azure subscriptions. We've got John Bowker, who's a CISO, a security officer at End Contracts. November 19th, we've got an architect, an engineer from Terraform who's going to talk, from HashiCorp rather, who's going to talk to us about Terraform. And then January 21st, we've got a talk on machine learning with or without a PhD. So hopefully we'll all be able to understand that. And that's Doug Starnes, and he's another Azure MVP and technical author. Tonight, this is our speaker. I'm going to turn, at this point, I'm going to turn the presentation over to our leading speaker. Anybody have any questions or comments before we do that, though? Okay, if not, take it away.
Thanks, Bill. Let me go ahead and share my screen. Give me a heads up once you're able to see my screen.
Yep, you see it. Okay.
Just give me a second. Let me set up my monitors. So I have 3 monitors. On one of the monitors, I am running my PowerPoint, and on the second one, I have pulled up the Teams meeting as well so that I can keep a track of the comments or questions on the chat window. All right,
I beat you. I'm surrounded by 5 monitors.
All righty, let's get started.
I'll be quiet now.
Hey everyone, very good evening. I would like to first of all thank Bill for giving me this opportunity to speak in this your user group today. As he already mentioned, I'm going to talk about Azure networking today. Just a level setting here. This will be a level 100 to 200 session, not a very advanced session today. I intend to touch upon different Azure networking services. I will not be able to deep dive into any of those particular topics that we are going to touch upon because it's just a 60-minute session. But I can assure you that it will be helpful to you if you are planning to learn more about Azure networking or if you are preparing for your Azure role-based certifications. Before I move on, I generally give few guidelines. If you can follow that, it would be great. If you have got any question or a comment or a doubt in between the presentation, please post it on the chat window. I will be checking that regularly and I will answer that as and when I get an opportunity. Or you can directly ask me any query you might have at the end of the presentation. I would be more than happy to hang out in this meeting after my presentation is over. And please stay on mute to avoid any distractions to others. And with that, let me start with my introduction fast. My name is Vaibhav Gujral. I'm based out of Omaha, Nebraska, currently working for Kivit Corp as a cloud architect. I am recently being awarded as Microsoft Azure MVP. I am a Microsoft Certified Azure Solutions Architect Expert, and I hold a few other Azure certifications. I also run Omaha Azure User Group, which has close to 900 community members trying to slowly catch up to Bill's group, but we are close to 900 today. And like Bill, we are also conducting our meetings online, and if you are interested, feel free to go and join our meetup group. We are available on Meetup, and we also have presence in other social media platforms as well. And you have my blog information listed there. You can also follow me on Twitter or contact with me over LinkedIn. With that, let's see what we are going to talk about today. We will start with Azure regions and data centers. We'll talk about virtual networks, VPN gateways, network security groups, how routing works in Azure. We'll touch upon different load balancing options that we have in Azure, and that would be pretty much. I would also touch upon the different network monitoring services that you can utilize in Azure to monitor your network traffic. I have planned a couple of demos also on the way, and we will see how much we can cover based on how it goes. Just a disclaimer, I have utilized some of the diagrams or the architecture figures that I've used in my presentation are taken from Microsoft's documentation. With that, let's start with it. So starting with the very basic first, I have been talking to so many people, and one of my observation has been that they really don't understand what an Azure region is. They generally mix up a region and a data center, which technically are not same. Everything in Azure does starts with a data center, which is analogous to your on-prem data center if you have one in your office. A data center, if I have to define, is nothing but a building or a group of buildings which are used to house physical infrastructure, including racks, network switches, and so on. Whereas a region in Azure is a collection of those data center buildings deployed within proximity with a network latency under 2 milliseconds. When I say proximity, it might be around 100 miles as well in some cases. Going further, Microsoft groups these regions into geographies to comply with the data residency and data compliance laws. Geographies can have more than one region under them, which makes them fault tolerant. Last but not the least, you shall also be aware of what an availability zone is. In Azure, availability zones are physically separate locations within an Azure region. Each availability zone is made up of one or more data centers equipped with independent power, cooling, and networking. So the advantage you get out of utilizing availability zones is uh, when you have business continuity requirements, but you want to have your resources within a single region, you can probably utilize availability zones to have your replicas in different data center buildings having different equipped with different power, cooling, and networking devices. What you see here is different geographies with their corresponding regions. There are 6 geographies altogether, starting with Americas, Europe, Asia Pacific, Middle East, and Africa, Azure Government, and Azure China. Each of these geographies, as you can see, have multiple regions within them, making each of these geographies fault tolerant. For example, Americas has 11 regions ranging from East US, East US 2, Central US, and so on. Likewise, Europe has 15 regions and Asia Pacific has 13 regions. And each of these regions then have different data center buildings. This gives a better view of the different regions in different geographies. The blue dots that you are seeing on the screen are the regions that are available for consumption, meaning you can deploy your services in any of these regions. The one with the dotted circles are the regions which are announced and are going to be available in recent future. Then you would also notice there are few of these circles with diamonds in them. It indicates that those regions have availability zones, which you can select when you are configuring or provisioning your resources in Azure. When you are choosing a region to deploy your resources, there are a few considerations that you should keep in mind. Certainly, the first and foremost are the data compliance and data regulatory reasons. You might have to choose a particular region. But you should also keep in mind that all the services are not available in all the regions. So I have provided a link over there for global infrastructure page where you can find out all the available products available within the individual region. So someone has posted the question saying, explain a sovereign versus public region, please. So which is very fair question. One thing you will notice here is there are few of these regions which are either gov regions or sovereign regions, which are not the commercial cloud regions. Those are intended for government regions and they are highly restricted. They have more restrictions compared to the commercial public cloud regions like East US 2 or if I take the example that someone has mentioned there, sovereign versus public region. So the public region can be utilized, it's a commercial region where anyone can deploy, any customer can deploy their services, whereas the sovereign region is more restricted and it can only be used by the government agencies. Now here is a snapshot of how many services Azure offers today. On the lower bottom is the Azure Data Center infrastructure, which is the physical infrastructure owned and managed by Microsoft. On top of that, you have infrastructure services ranging from your compute services, storage services, and your core networking services. On top of infrastructure services, you have platform services, which are customized to suit different needs like web services, integration services, and data services. On the left side, you can see the suite of management services, which you can utilize to manage your Azure environments more efficiently. These include services like Azure Blueprints, Azure Policies, Azure Monitor for alerting and monitoring, and so on. Towards the right, you can see all the security services that you can utilize to improve your security posture in the cloud. It includes services like Azure Security Center, Azure Active Directory, which is a cloud identity store, and so on. Anyways, we are going to focus on the networking services today. As mentioned earlier, we will be looking into some of these services like virtual network, VPN gateway, load balancer, and so on. Let's start with the building block of a private network in Azure, which is nothing but a virtual network. In Azure, being a private network, a virtual network brings isolation on top of other features that a public cloud offers, like scalability and availability. You can place your Azure resources inside a virtual network to securely communicate with each other, as well as with your on-prem networks and with your internet resources. A virtual network is analogous to a traditional network that you would manage and operate in your on-prem data centers. If you are not aware of, when you create any private network, you define an RFC 1918 IP address spaces. Likewise, since virtual network is a private network, you have to define RFC 1918 IP address ranges. If you are not aware of RFC 1918, I would strongly encourage you to read about it. I have provided a link for your reference on this slide. In a nutshell, it specifies the best practices for defining the IP address schemes for your private networks. Basically, it categorizes the different private networks or the IP address spaces for your private networks into three main categories, depending on the access levels for your hosts, starting with if your host can only be accessible within your enterprise is the first category. Then the second category is where your hosts can actually has full access within your enterprise but have limited access outside your enterprise. And lastly, the category of hosts which have network layer access to the resources even outside your enterprise. So the host which can have access outside your enterprise as well, they cannot really have overlapping IP addresses, whereas the first category and the second category where we have restricted access outside your enterprise, they can have their own private IP address spaces which might overlap with other enterprises. Now, RFC 1918 standard allows three different IP ranges that can be used within a private network, which are listed over there, starting from 10.0.0.0, 172.16.0.0, and 192.168.0.0. When creating a virtual network, you have to define the IP address ranges in CIDR notation, which is basically based on the idea of subnet masks. If it requires you to provide the IP ranges in basically two parts, as you can see in the example I have provided there. The first part is the network identifying prefix, followed by a host identifier within that network. The highest prefix that you can have is could be /32 in Azure virtual networks, and the number of IP addresses double with every reducing prefix. The example that I have taken has /24 as a prefix, which denotes 256 IP addresses. The lowest prefix you can have in your Azure virtual network is /16, which translates into 65,536 private IP addresses. Once you define your virtual network, you can further segment your network using subnets. You can have up to 3,000 subnets within a single virtual network. The traffic is enabled by default between the different subnets within a virtual network. Since essentially they are part of the same IP address ranges, it's just the network segmentation within the network. It is important to understand that a virtual network is scoped to a single region and a subscription. So what you are essentially seeing in the diagram towards the right is how it is laid out in Azure when you create a virtual network within a subscription or resource group. You have your subscription sitting in your region, and then you have your resource group within your subscription. Under the resource group, you have virtual network. Within virtual network, you can have multiple subnets, and within each of those subnets, you can have multiple resources. It is important to keep the scope in mind, how virtual network scoping works, because you cannot have a virtual network with the same name in the same scope. Moreover, it is also important that you should plan your virtual networks across different regions and subscriptions in a way that they don't have overlapping IP ranges, because if they have overlapping IP ranges, then in future, if you intend to join those two virtual network together, you will not be able to do it. We'll touch upon this aspect in later slides, but just keep a note of that. All resources in a virtual network can communicate outbound to the internet by default, but if you need to enable your inbound communication to your resources from internet, you have to utilize public IP addresses or a public load balancer. Some best practices that you should follow while you are designing your virtual network estate in Azure. Always avoid non-overlapping address spaces, as I was mentioning in the last slide, because in future, if you intend to join your virtual networks, then overlapping address spaces will not let you do that. Then ensure that your subnets don't cover the entire address space of the virtual network. For example, if I have my virtual network address space with prefix /24 or /21, don't create subnets with the same address space. Rather than have a small address range or address space for your subnets, so that you will be able to save some additional address space for the future needs that may arise as your Azure environment or your Azure usage grows. Next is when you are designing your virtual networks, it is always better to have fewer large virtual networks, meaning virtual networks with larger IP address space, rather than having multiple small virtual networks with smaller IP address spaces. It will help you avoid management issues, because if you'll have multiple VNets, then you have to manage them all. Lastly, you shall secure your virtual networks with network security groups. You can define incoming and outbound rules. We'll have a demo later in this presentation where I will show how you can add those rules, but do ensure to secure your virtual networks with network security group. I have mentioned a link down below there. Please go ahead and check it out for further guidance on how you can better plan and design your virtual networks. With that, let me first jump onto Azure portal and see a quick demo. So this is the Azure Global Infrastructure page. If you are not aware of that, I will suggest go and use your search engine of your choice, Google or Bing or whichever you use. Go ahead and look up for Azure Global Infrastructure and head out to this page. You can find all the information about the Azure global regions, the geographies, the data centers, and the products that it supports. If you can go ahead and see the products which are supported in each region. You can go ahead and, let's say if I want to see all the products which are supported in United States region, you can see all the different category of products across the different services, what is available in which region, and is it in preview? If it is in preview, when it will be available, if it is announced and a particular service will be available in future. So good stuff. Go and check it out when you are designing your region in virtual network strategy. If you are intending to utilize any of the network services and create any networking resource in Azure portal, head out to create a resource or the new resource Blade, go ahead and look into all the networking services. There is a separate section for networking where you can see all the different kinds of networking services that Azure offers. These are the featured ones. If you click on see all, you can see all the available networking services available in the Azure marketplace. Some of them are all core networking services offered by Azure. Some of them are offered by Microsoft partners and third parties. For this particular demo, I'm going to show you how to create a virtual network. Once you click on create a virtual network, it will ask your subscription details. It will ask you to choose a resource group. I have already created a resource group for my demo. You can name it based on the naming standards or the naming strategy that you have in your organization. You can choose the appropriate region that you want your virtual network to be created. Next, you have to define the IP address space for your virtual network and the underlying subnets. So by default, it is giving me an option for /16, which creates 65,536 IP addresses. And that's the max number of IP addresses that I can have in my virtual network. I can go ahead and select /24, which gives me a smaller number of IP address because I don't need more than that. You can opt for if you need IPv6 address spaces or do you need IPv4. I don't need IPv6 address spaces for now. And I can go ahead and add a subnet as well. And leave it a name default. As you will see here, what happens is it says out of 32 IP addresses, which are included in /27 prefix, 27 are available for your use, whereas 5 are reserved by Azure for the virtual network and the subnet configuration. I will touch upon service endpoints. For now, I will just go ahead and add. So as you see, my IPv4 address space for virtual network is /24, whereas I have selected a smaller subnet, but I can still, nothing stops me from going and creating a subnet range with /24 prefix. You can create we'll talk about some of these features in later slides, but you can go ahead and enable any of those features upfront for your virtual network at the time of creations. You can define tags. I'm going to leave that as is. I'll click review, press create, and I'll go ahead and shows the validation has passed. My virtual network configuration looks good to Azure, and it will go ahead and provision my virtual network. It might take a minute or two, if not less than that. It is already created. If I will show you, here is my address space that I have provided at the time of creation. Here's the resource group that it sits in. Here the subscription that I had. I can see my address space. Sooner or later, if my virtual network goes out of IP address range and I need to add further more IP addresses, I can just go here and add my IP addresses in this and click on save, and it will extend my virtual network IP ranges. I can go and see the subnets that I have. I have created this default one. I can in future, if I have to create further subnets, I can go ahead and create it here. And this was the point that I was trying to make earlier in the best practices slide, that you should not utilize your complete address space in your subnet that's available in virtual network, so that in future you can add further more subnets and extend your virtual networks that way. With that, let's keep moving. So what we have just seen now is what a virtual network is. Let's talk about a VPN gateway. A VPN gateway is a specific type of virtual network gateway that is used to send encrypted traffic between an Azure virtual network and an on-prem location over the public internet. You can use a VPN gateway to send encrypted traffic between Azure virtual networks as well over the Microsoft network, but though it's not the recommended way or the best way to do it. We'll see why and how in later slide. But in essence, the VPN gateways can be utilized to send encrypted traffic between an Azure virtual network and your on-prem network. Now, each virtual network can have only one VPN gateway However, you can create multiple connections to the same VPN gateway through your VNets. When you create multiple connections to the same VPN gateway, all VPN tunnels share the same gateway bandwidth, which is important to note. I will cover in the next slide what it translates to. Keep a note of the different types of VPN gateways that you can use. There are two types of VPN gateways, VPN and ExpressRoute. And now I just said that before mentioning the types that you can only have, each virtual network can have only one VPN gateway. I would like to correct that statement by saying that a VNet can have just one VPN gateway of type VPN, and it can also have one VPN gateway of type ExpressRoute. So essentially it can have two VNet gateways, VPN gateways, but each of them should be of different type. Lastly, when you create a VPN gateway and attach it to a virtual network, it creates an exclusive subnet called as gateway subnet in the virtual network that is used to host the underlying resources that are required to enable that gateway. Our VPN gateway does supports different connectivity scenarios. If you have networking background, we can have point to site, site to site connectivities. So VPN gateway does supports that. To start with, as I was saying earlier, that VPN gateway does lets us connect our Azure virtual networks among themselves, those virtual networks could be in same or different regions, subscriptions, or deployment models. If you are not aware of different deployment models, there used to be classic model in the past. Now it's called Azure Resource Manager. If you already have created classic virtual networks in the past, you can connect them to your ARM-based virtual networks using VPN gateways. VNet to VNet gateway creates, basically, as you can see in the diagram down there, it creates an IPsec or IKE VPN tunnel between the two virtual networks that you connect through VPN gateway. And a VPN gateway sits in front of each VNet, and VPN gateways then talk to each other to enable communication between the two virtual networks. Pretty straightforward. Likewise, you can also establish, as I said, VPN gateways are required to connect your on-prem networks with our Azure virtual networks. So the first connectivity model it supports is a site-to-site VPN gateway connection. It provides a connection over IPsec IKE VPN tunnel. Site-to-site connections can be used for cross-premises or hybrid configurations. It requires, basically, if you have, since most of us have been working remotely now, you might have been utilizing a VPN connectivity to your enterprise. Likewise, for a site-to-site connection through VPN gateway to work, you have to install a device you need to have a device located on-prem that has a public IP address assigned to it, and then you also need to have agents installed on the different devices that might connect to it. Please note that you need to have a VPN devices located at each of the locations that you are trying to connect to your VPN gateway. And each of the tunnels that you, each of the tunnels that you are seeing here utilizes the same bandwidth. I mean, they share the bandwidth available at the gateway. So if, let's say, the bandwidth available at the gateway is 1 Gbps, then that bandwidth is divided among all the tunnels that are VPN tunnels that are created through that VPN gateway. The another model that it supports is point to site VPN connectivity between your Azure virtual network and to your remote clients. And like I was mentioning, in the site to site connectivity, the bandwidth is shared across all the tunnels as well. So if your VPN gateway has 1 Gbps bandwidth, then that will be divided among all those 3 different tunnels that are created. As I mentioned earlier, one way to connect your VNets is certainly VPN gateways, but they are not the best way to do it. The recommended way to connect multiple virtual networks is through virtual network peering, where you can connect your one virtual network with another. The result is that the IP address ranges of the virtual network peers essentially appear as a single virtual network, and the resources between both the virtual networks can communicate with each other as if they are the part of same virtual networks with minimal latency. Depending upon the location of the virtual network or region in which the virtual network peers are in, the peering might fall under one of the two categories, which I have listed down there. If both your virtual networks are in same region, let's say East US 2 or Central US, it is counted as virtual network peering. If the virtual networks are in different region, it is counted as global network peering. You might have to be aware of the cost implications for both the peering types here. For the first virtual network peering, which is the intra-region peering, you pay for inbound and outbound data transfer at both virtual networks. And not only for, but that's true for both, but the cost for virtual network peering is lower than the global virtual network peering. And the reason for that is because Azure charges for any data that goes out of a particular region. That increases the cost of your global virtual network peering. Another thing to note here is that VNet peerings are not transitive, meaning what you see in that diagram down below is when virtual network A is paired with virtual network B, and virtual network B in turn is paired with virtual network C. Here, virtual network B can communicate with both A and C, but virtual networks A and C cannot communicate with each other. They can though communicate with B, because that makes VNet peerings are transitive. You have to peer two VNets if you want them to talk. If B is connected to both A and C, that doesn't imply that A and C will be able to talk to each other. Lastly, having VNet peering doesn't stop virtual networks to be attached to a VNet gateway. And when you are doing VNet peering, you don't have to essentially attach virtual network gateways to each of these virtual networks. If one of your virtual networks is attached to a VNet gateway, you can utilize that same gateway with your peered virtual network as well through gateway transit, which I will show in a demo soon. What you are seeing here is a network topology, which is very commonly implemented across enterprises. It's called hub and spoke topology. I have listed a link down below there if you want to read about it in details. In a nutshell, you create a hub virtual network and peer multiple spoke virtual networks to the hub. The hub can be connected to a VPN gateway or something known as an ExpressRoute. For on-prem connectivity, we will talk about ExpressRoute in a moment. Generally, hub virtual network is the central point of connectivity between the Azure environment and your on-prem network. It is used for deploying management resources and shared resources like firewalls and your gateways and your jump box machines and so on. And then your spokes have the other resources that are used by your spoke subscriptions and your spoke applications. And the spokes are essentially the isolated workloads which can be managed independently. Using hub and spoke does offer some benefits. It improves your management of these networks. It might result in cost savings depending upon how much data flows between hub and spoke and so on. I was mentioning about the ExpressRoute in the last slide. ExpressRoute provides layer 3 connectivity between your on-prem networks and the Microsoft cloud over a private connection, may be facilitated by connectivity provider. With ExpressRoute, you can also establish connection to Microsoft online services like Office 365. Connectivity can be from any to any, or it could be a point-to-point Ethernet connection, or it could be a virtual cross connection through a connectivity provider at a co-location facility. ExpressRoute connections do not go over the public internet, and that is what it distinguishes. That is how it is distinguishable from virtual network gateways. This allows, since ExpressRoute connections do not go over the public internet, it does allows ExpressRoute connections to offer more reliability and be more secured. Under the hood, Microsoft uses Border Gateway Protocol, or the BGP, to exchange routes between on-prem networks and your Azure environment or your Azure networks. Each ExpressRoute, you shall note here, consists of two connections to Microsoft Enterprise Edge routers. As you can see there, one connection is color-coded red, the other one is color-coded. One one connection is the primary connection and the other one is the secondary connection there. The primary reason behind that is so that Microsoft can ensure that the connections are handed off in a redundant manner. Each circuit, as I have listed down the bandwidth, fixed bandwidth that you can specify for your ExpressRoute. It can range from 50 Mbps to up to 10 gigabytes per second. And last but not the least, do consider the pricing models when you are creating your ExpressRoute circuits. The first tier is metered, where, as the name suggests, your data outbound transferred is metered. The other one is unmetered, where there is a fixed cost and the outbound data transfer is not metered. So when you are trying to implement ExpressRoute, do note that you can scale up your ExpressRoute pricing tier from metered to unmetered, but you cannot do vice versa. Once you meaning you cannot change your unmetered ExpressRoutes back to metered. You have to drop the circuit and create it again. Lastly, check out a couple of other options available in ExpressRoute space. The ExpressRoute Direct, where you can connect directly to Microsoft's global network without the need of a service provider. You don't need a co-location provider in between, the connectivity provider in between. And for the ExpressRoute Global Reach, which lets you link your ExpressRoute circuits in different regions to connect together to make a private network between your on-prem networks. For ExpressRoute, when you are provisioning your ExpressRoute circuits, do note that there are two independent peerings that you can have. You can either have private peerings or you can have Microsoft peerings. Private peerings lets you connect your on-prem networks to your Azure virtual networks, and your Microsoft peering lets you connect your on-prem network to Microsoft online services like Office 365. If you have been utilizing old ExpressRoute circuits, they might show three different peerings: Azure Public, Azure Private, and Microsoft. Azure Services earlier were categorized into Azure Public and Azure Private. Now they are just private peerings. Now, each peering here that you are seeing is a pair of independent BGP sessions. Each of them is configured redundantly to ensure high availability. And an ExpressRoute can have only one or two or both of the peerings enabled per ExpressRoute circuit. There are three different ways you can establish connectivity through ExpressRoute. You can have co-located. If you are co-located in a facility with a cloud exchange, you can order virtual cross connections to the Microsoft cloud through the co-location providers Ethernet exchange, as you can see towards the leftmost image. Co-location providers offers either layer 2 cross connections or managed layer 3 cross connections between your on-prem networks in the co-location facility and the Microsoft Azure connections. Oops. Likewise, you can also use point-to-point Ethernet link for layer 2 or layer 3 connectivity, as you can see in the second diagram. And lastly, you can also integrate your WAN with the Microsoft cloud through ExpressRoutes. Microsoft has a global network with ExpressRoute connectivity providers and system integrators. There are different set of providers in different regions. So to get a location-wise list, I highly encourage you to check out the link that I have provided down below there. What you see here is a failover scenario for an ExpressRoute, which is used to connect your on-prem resources with Azure resources. In case of an outage, a site-to-site VPN through VNet Gateway is used as a failover connection. If my ExpressRoute is up and running, traffic flows between the on-prem network and the Azure virtual network through that ExpressRoute connection. If there is a loss of connectivity in the ExpressRoute circuit due to any XYZ reason, due to the co-location providers, connectivity providers issue, or through an outage at Microsoft Azure's ExpressRoute circuit, the traffic can be routed through an IPsec VPN tunnel through VPN Gateway. I have provided a link to the reference architecture. For the reference architecture I'm showing here, please do check it out if this is something that might work for your organization. There's another networking service called as Azure Virtual WAN, which brings many networking, security, and routing functionalities together to provide a single operational interface. These functionalities might include site-to-site VPN connectivity or point-to-site connectivity. You can have ExpressRoute connectivity through it, or you can also have branch connectivity. You can establish Azure Firewall or intra-cloud connectivity. You can connect your different clouds together. Again, the point is it's a WAN, so you don't essentially have to use all these features all together. You can use a subset of the features depending upon your use case. Now, under the hood, the virtual WAN architecture is a hub and spoke architecture with scale and performance built in for branches, users, ExpressRoute circuits, and virtual networks. As depicted in this diagram, Azure region serves as hubs that you can choose to connect to, and all hubs are connected in full mesh in standard virtual WAN, making it easy for the user to use the Microsoft backbone for any-to-any connectivity. Moving on, I would like to touch upon a few features which are part of virtual networks, which come in very handy to connect your Azure services privately and securely. When I was showing the demo earlier on virtual network, I did mention about the service endpoint when I was creating the virtual network. To start with, the service endpoint allows your resources within your virtual network to reach to other Azure services with a private IP address. You just need to enable the service endpoint on a subnet for the particular Azure service at the time of creation, or you can do it later as well. I was showing you in my demo when I was creating the subnet. Do note that there is no additional cost for using a service endpoint because it does let your resources within your VNet to just reach out to other Azure services using their private IP address. A newer service that has been released recently is known as Private Link or Private Endpoint, which enables access to Azure PaaS services over a private endpoint in your virtual network, as depicted in the diagram. The traffic flows on the Microsoft backbone network, and there is no need to expose services to public internet, as you can see towards the right of that diagram. Microsoft has already announced support for private endpoints with some of the services like Azure SQL databases, Azure Storage. For some of the other PaaS services like Azure App Services, it is still in public preview, and I assume next week is Ignite, and it might be announced next week, or it might be later announced GA. I'm really expecting few more services to be added under Private Link, and they have been adding these services every week or every month. I have found personally the feature to be very powerful, and do check it out. Lastly, I also want to mention about another feature known as Virtual Network NAT or Network Address Translation. Many times there is a requirement to expose a single static public IP address on outbound communication from your resources running inside a virtual network. For such situations, you can use Virtual Network NAT, which once enabled, forces all the UDP and TCP traffic to flow from the resources under the subnet to use a NAT and to show this static public IP address that you have assigned it. Now you can opt for a single static public IP address, or you can also opt for a public IP prefix with your virtual network NAT. To configure, you need to set up a NAT gateway with a public IP address or an IP prefix and assign it to the subnet, as you can see on the diagram towards the right. Let's talk about the network security groups. As I was mentioning in my best practices slide about virtual networks, that you should secure your virtual networks using network security groups. Essentially, network security groups allows you to filter your network traffic to and from your Azure resources sitting inside your Azure virtual network. Network security group contains security rules, essentially that allow or deny inbound network traffic to or outbound network traffic from your virtual network. For each rule, you can specify the source and destination, the port, and the protocol. I will show you a demo how we can do that. When you create an NSG, there are some default security rules automatically created, and you can override those rules with your own security rules with by providing a higher priority. I will show you a demo shortly. You can also have augmented security rules, which allow you to define larger and complex network security policies with fewer rules. For example, you can use something like service tags in your NSG rules that represent a group of IP address prefixes from a given Azure service, like an Azure App Service or an Azure Storage, and so on. I'll show you that as well in the NSG demo. Now, network security group security rules are evaluated by priority. That's why I was saying you can override the default security rules by providing your custom rules a higher priority. The rules are evaluated using a 5-tuple information, and that 5-tuple is basically formed by utilizing source port, destination port, and the protocol of your communication to allow or deny the traffic. As you can see in the figure towards the right, NSG can be applied at the NIC level or at a subnet level. To the left, you see there is a NSG at NIC level as well as at the subnet level. NSG1 that you see is at subnet 1 level. NSG2 is at the network interface level. And all the security rules in both the NSGs are executed, and preference is given depending upon the direction of the communication. For example, for inbound traffic, the rules at the subnet level NSG, the NSG1 are evaluated first, and then the rules in NSG2 are evaluated. If the traffic is allowed at the subnet level, but not at the NIC level, meaning if the traffic is allowed at NSG1 and not at NSG2, the traffic is denied. Likewise, if it's the outbound communication, meaning traffic going out from your virtual machine 1 to outside, the rules at the NSG2 level are evaluated first, and then the rules at NSG1 are evaluated. Likewise, for virtual machine 2, if you will notice, there is no NSG at the NIC level, and the rules from the subnet NSG, meaning NSG1, are applied to all the traffic. For virtual machine 3, there is no NSG at the subnet level, though there is a NSG at the NIC level. So the rules at the NIC level NSG applies to all the inbound and outbound traffic. Lastly, for the virtual machine 4, there is no NSG absolutely, so there is no restriction on the inbound or the outbound communication. Now, the challenge with NSGs is that you have to base your network security policies on IP address ranges or the composite rules, but which is okay in many cases, but sometimes it gets tricky to set up the network security policies that align with your application hierarchy or your application organization. Meaning, if I have to group my database virtual machines, my database servers, and define network security policies based on those groupings, it is not possible to do that with NSGs. The problem can be resolved using something known as application security groups, which allow us to configure the network security policies as an extension of an application structure. To give you an example, if you will notice in the figure towards the right, NIC1 and NIC2, the network interface card 1 and network interface card 2 are the members of application security group ASG Web. NIC3 is a member of ASG Logic application security group for my business layer, and NIC4 is a member of my database application security group. Now, none of the network interfaces have an associated network security group here. NSG1 is associated to both subnets. My network security group that you see towards the left is associated to both of my subnets and contain certain rules with the application security group as either the source or the destination. The advantage that I get out of using application security group as a source or a destination in those rules in NSG1 is that all the rules that applies to all the NICs that are assigned to application security group. Meaning, if I apply the rules in NSG1 to an application security group, let's say ASG Web, then that particular rule just applies for VM1 and VM2 and not on the VM3, because VM3 sits in a different application security group. Moving on, you can also use an Azure Firewall to secure your Azure Virtual Network resources, just like any other firewall. It provides it filters your incoming and the outgoing traffic. Azure Firewall is fully managed cloud-based network security service. It is a fully stateful service that comes with built-in high availability and unrestricted cloud scalability. It comes with some out-of-the-box features like service tags and built-in high availability and so on. But essentially, under the hood, it works pretty much the same like any firewall. You can have your own rules to allow or deny the traffic to your resources. Moving on, just for the benefit of people who don't know what DDoS is, denial of service attack is a cyber attack in which the malicious party might seek to make a machine or network resource unavailable by its intended user by temporarily or indefinitely disrupting services of a host connected to the internet, by flooding the targeted machine with requests in an attempt to overload system and prevent some or all illegitimate requests from being fulfilled. Using Azure DDoS protection, you can protect your Azure resources in your virtual network from DDoS attacks. Basic DDoS protection is free of cost and is already enabled as part of the Azure platform. You can also opt for standard DDoS protection in Azure, which comes with additional support options and mitigation capabilities. For most of the use cases that I'm aware of, basic DDoS does a good job, but still, if you intend to use standard tier, go for it. In the standard tier, the policies are applied to public IP addresses associated to resources deployed in virtual network. You can utilize Azure Monitor for real time. Do note that those are just the basic differences between the two tiers, and both the tiers does support IPv4 and IPv6 public IP addresses. Let's jump on to a quick demo. So what I have done is I have already set up 3 different resource groups. The first thing I'm going to showcase is VNet Peering. So I have my resource group 1, I have my resource group 2, and I have my resource group 3. Essentially, in each of those resource groups, you can see I have provisioned a virtual network, VNet 1, with its own IP range 10.0.0.0/24. Likewise, RG2 has its own virtual network here, VNet 2, which has its own IP address range, and RG3 has its own virtual network. Then within each of those resource groups and virtual networks, I have provisioned a virtual machine, VM1, which has its own public IP address, which has its own NSG, which has its own NIC interface, and it has its own disk. Likewise, you can see it in the other resource groups. I have created virtual machines. So I have already remote desktoped into all the 3 different machines. Let me show you the IP config for all 3 of them. As you will see, this 10.0.0.4 is my virtual machine 1, which sits in the virtual network 1. The second one is 10.0.1.4, which is for my virtual machine 2, and it sits in virtual network 2. And my third virtual machine has IP address 10.0.2.4, which sits on my virtual network 3. Now let me show you that my virtual machines are in different virtual networks and they cannot connect to each other. Let me go and ping these from each other. 10.0.1.4. You can see my VM1 and VM2 cannot speak to each other. Let me go back to the Azure portal and enable virtual network peering. So what I'm going to do is I'm going to go to my resource group 1 here and go to my virtual network, which is going to be one of the peers in the setting. Now within a virtual network, you can head out to peerings section, go ahead and click on add. It will ask certain details from you. You can, to start with, give the name of your peering. I will call it VNet 1 to 2. It's an ARM type. I was mentioning about the deployment models earlier. Since my virtual networks are Azure Resource Manager based. So I will use Resource Manager. I will choose my subscription. I will choose the second peer for my virtual network 1. I want to pair my virtual network 1 with virtual network 2. And it will ask me the name that for the peering that it will go ahead and automatically add on the virtual network 2 as well. I will name it virtual network 2 to 1. So basically the peering that I have provided a name here, it creates this peering on virtual network 1, and the name that I have provided here, it creates this peering in the virtual network 2. I can disable connectivity between virtual network 1 to 2 and vice versa, but I want to keep them enabled to complete my demo. I can also opt for forwarding traffic from virtual network 2 to 1 and vice versa. I will keep it default option to be disabled. And when I was talking about VPN gateways, I did mention that if virtual networks are peered and one of them virtual network has a VPN gateway, the peer network can also utilize the VPN gateway. And to do that, to enable that, I can go ahead and opt for gateway transit here. By default, it is not selected, and since I don't have any VPN gateway set up in my environment, it doesn't make any sense for me to go ahead and do it. But if you have a use case like that, you can do so by checking this checkbox. I'm going to click OK and let it add the peering for me, and then we'll go back to my virtual machines and see if that connectivity is established. So you see that it has already added peering on my virtual network 1. With the name, it says the peering status is connected, and the peer is virtual network 2. I didn't opt it for gateway transit. That's why it says disabled. I'll show you what it shows under VNet 122 peering. It shows the different properties that I have selected. Later, if I have to allow gateway transit, I can do that. And the properties that I did not selected while provisioning peering, I can go in and make changes here as well. Likewise, if I go to my resource group 2, I can show you the peering that I added will show up in virtual network 2. If I go here and go into the peering field, this was the peering that I added here. If I go into the resource group 3 and show you the virtual network 3, you will see that there is no peering here, meaning my resources in virtual network 1 and 2 should be able to talk to each other, but none of them should be able to talk to my resources in virtual network 3. So meaning the first virtual machine, this should start working now. And you go, so it has started getting response from the virtual machine 2. Likewise, if I go ahead and ping the first machine, it does starts getting response from the virtual machine 1. Now this particular machine towards the bottom is the one which is running in the third virtual network, which is not peered to any other virtual network. Let me try pinging any one of the other machines, and then as expected, it should time out. And as you see, it is timed out. Now this is how I have enabled my virtual network peering, but I have been doing a ping operation, which is based on ICMP protocol. To demonstrate my demo on NSG, let me go back to one of the resource groups and pull up the NSG. So here, my virtual machine 1 NSG is applied on virtual machine 1. So any inbound or outbound rules that I will define will apply on that NIC. You can go ahead and you can see the network interfaces that it is assigned to. It says the NSG is assigned to VM1219 network interface, which is attached to my virtual machine 1. I'm going to go back in my NSG and show you the inbound security rules and outbound security rules. So as you can see, it did added these last 3 incoming rules automatically. Likewise, it did added these 3 rules automatically for outbound. You do see here a rule for RDP, which I have added earlier when I was provisioning my virtual machines, so that I can do a RDP session on my virtual machine to show a demo. The moment I go ahead and delete this rule, it will not let me remote desktop into my machine anymore. But to give you an example of how powerful it is, let me go ahead and add a rule to block any ICMP traffic. So I leave my source here anything, but when I was saying about earlier the different ways you can define your rule. You can assign your rule either on an application security group level. You can assign a service tag, or you can use an IP address space here, or you can use any refers to internet, any traffic coming from anywhere will be allowed. So I leave my source and destination to any. I'm choosing the protocol as ICMP, and I'm choosing my action as deny. And this is where I was saying it takes it executes these rules based on the priorities. So I do ensure that my rule has priorities higher than 65,000 so that it gets executed before the default rules are executed. I'm going to it automatically capture 310. I will keep it as is. I will name my rule as block ICMP. Now this is an incoming rule, so any ICMP request coming from outside to my virtual machine 1 should be blocked. So now this rule is applied. If I go back to my virtual machine, if I go back to this thing, and I can see my effective security rules, it will pull up all the effective security rules that are applied on my NIC through the NSG listed here. So it will go and grab all those inbound and outbound rules and show it here. As you can see, it still doesn't have the rule that I have added. Probably it is gonna take a minute or so before it gets reflected here. You see that new rule that I've added has started reflecting here. It's a deny rule. Let's go back to my virtual machines and show it. So this is my virtual machine. The outbound traffic is still open, so I should be able to ping any outbound traffic. But if I go ahead to my virtual machine 1 and try to ping my virtual machine 1, it should fail now. The reason being because it is being blocked by NSG now. And as expected, it turns out because my NSG is not letting that traffic go. So what I'm gonna do next is, just to prove that yeah, it has been blocked by my NSG, I'm going to delete that rule. It takes few seconds before it can delete the rule. I will go back to my network interfaces. I will see if the effective security rule is, what are the effective security rules? It will take a few seconds to refresh, and the rule still exists. It might take a few seconds if more before it can update that. And the moment that rule is gone, I should be able to ping back my virtual machine 1 again. Oh, it's still not updating there, but let me go and try and see here if it is still up. No, it's still not, because my network security rule still exists there. It should be gone now, because you can see first time it timed out, but then it started coming back. And as you see, that rule has gone. It's not there yet anymore. So that's pretty much how NSGs can be utilized to demonstrate to secure your virtual networks. Let's talk about routing quickly. Whenever a subnet is created within a virtual network, a route table is automatically created by Azure with the system default routes already added to the table. Now, Azure system default routes can be overridden with custom routes if you have to. All the outbound traffic is routed on the routes in the subnets route table. What you see down there is the route entries from the route table. The point to note there are the next hop types. You can see three different kinds of hop types which are added. And starting with the virtual network, internet, and none. As the name suggests, for virtual network next hop type, the traffic is routed between the IP address ranges within your virtual network. For the internet next hop type, the traffic is routed to the internet, and for none next hop type, the traffic is dropped. Also, we did talk about capabilities like VNet peering and VPN gateways. For such features, Azure also adds additional default rules. That's why you see three different next hop types there, one for virtual network peering, one for virtual network gateway, and one for virtual network service endpoint. When you create a virtual network peering between two virtual network, a route is added for each address range within the address spaces of both the peered virtual networks with the hop type as VNet peering. For virtual network gateway, route is added when virtual network gateway is added to a virtual network, and likewise when a virtual network service endpoint is added on a subnet, that is when this particular route is added on the route table. Now, those are the default routes, system routes that get added to the route table when you perform any operations on your virtual network. Over and above that, there are situations where you might need to either override those default routes, or you might also have to add your own custom routes. You can do so by having your own custom user-defined routes added to the route table. You can, I believe, have maximum of 400 user-defined routes inside a route table. You can specify a variety of next hop types ranging from a virtual appliance. If your traffic is coming through a virtual appliance, a virtual network gateway, as I was mentioning in the last slide, is used as an hop type when the traffic is destined for specific address prefixes routed to VNet gateway. VPN or the virtual network hop type is virtual network, internet, and none hop types are similar to what we just talked about in the earlier slides. Now, please note that when you don't see VNet peering and virtual network service endpoint here, as I was showing you here, the virtual network gateway and virtual network service endpoints in this list of hop types. In the user-defined route types, the reason being that the routes with the VNet peering and virtual network service endpoint next hop types are only created by Azure when you configure a virtual network peering or a service endpoint, and you generally don't need to change that. Now, you can also exchange border gateway protocol or the BGP routes between your on-prem network gateway and Azure virtual network gateway. It is used with VPN gateways of ExpressRoute type. Remember, I mentioned there are two categories of VPN gateways, VPN and ExpressRoute. So for the ExpressRoute types of VPN gateways, you can use these. You must use BGP to advertise on-prem routes to the Microsoft Edge router. You shall note that you cannot create user-defined routes to force traffic to ExpressRoute virtual network gateway if you deploy a virtual network gateway of type ExpressRoute, but you can define user-defined routes for forcing traffic from the ExpressRoute to a network virtual appliance, though. Moving on, as a general practice, administrators generally have a jump box virtual machine to connect to other virtual machines in their virtual network. For your Azure virtual machines, you don't really need a jump box machine anymore. If you have not heard of, there is a new service called Azure Bastion service, which is a fully platform managed PaaS service that provides secure and seamless RDP or SSH connectivity to your virtual machines directly in the Azure portal. When you connect via Azure Bastion, your virtual machines do not need a public IP address, which I think is a huge win or a huge selling point for Azure Bastion. If you have not checked it out, I will strongly encourage you to go and check Azure Bastion. Moving on, Azure provides many options to load balance your workloads. Starting with the first service you shall be aware of is Azure Load Balancer, which works at layer 4. It distributes the inbound network traffic across a backend pool, which could have plain instances of virtual machines, or it could also have virtual machine scale sets There could be two types of load balancers. It could be a public load balancer or an internal load balancer. As the name suggests, public load balancer is used for load balancing internet traffic to your VMs, whereas internal load balancer is used for load balancing within a virtual network. For public load balancer, you do need to use a public IP address for your front-end configuration so that internet traffic can reach to your load balancer. Whereas for internal load balancer, you need to use a private IP address. For load balancing the network traffic among the different instances in your backend pool, a load balancer essentially uses a 5-tuple hash. The hash is formed of the source IP address, source port, destination IP address, destination port, and IP protocol number. The hash is used to map traffic to the available servers. The algorithm provides stickiness only within a transport session so that packets that are in the same session are directed to the same data center IP behind the load balanced endpoint. When the client sends a new session from the same source IP, the source port actually changes and causes the traffic to go to a different data center endpoint. Uh, if you intend to solve that problem, you can also utilize source IP affinity distribution mode within our Azure load balancer. Which lets you utilize a 2-tuple or a 3-tuple hash to send your data, to send your traffic. If it's a 2-tuple hash, it utilizes source IP and destination IP. If it's a 3-tuple hash, it also utilizes protocol type on top of the IP addresses. For both types of load balancer, Azure offers a basic and a standard SKU that have different functional performance, security, and health tracking capabilities. The point to note is SKUs are not mutable, meaning once you create a load balancer with a specific SKU, you cannot really change the SKU. You have to create a new load balancer with the right SKU and migrate the configuration from the old one. Next service you shall be aware of is an Azure Traffic Manager, which uses DNS to direct client requests to the most appropriate service endpoint based on a traffic routing method and the health of the endpoints. An endpoint is not necessarily supposed to be within Azure. It could be any internet-facing service hosted anywhere outside Azure or within Azure. The point to note here is that Traffic Manager works at the DNS level. Traffic Manager uses DNS to direct clients to a specific service endpoints based on the rules of the traffic routing method. Technically, clients connect to the selected endpoint directly and not through the Traffic Manager, as you can see in the diagram towards the right. And Traffic Manager is neither a proxy nor a gateway. Do note that it does not see the traffic passing between the client and the service. It just routes the traffic through the DNS. There are certain traffic routing methods that you can use in your Traffic Manager configuration, ranging from priority, weighted, performance, geographic, multi-value, and so on. To give you a better explanation, priority is where your routes are selected based on the priority. Weighted is where you define the weights for your endpoints, and so on. In this particular diagram, the comparison that I'm showing you, on the left, you can see a system with priority routing in Traffic Manager, and to the right, you can see a weighted routing. When primary application goes down in the left diagram under priority routing, the traffic is routed to the next app instance in the order of proximity. Whereas in the second screenshot, when the primary site goes down, it sends the traffic based on the weights. Next service you can use for load balancing is known as Azure Front Door Service, which is a layer 7 load balancing service with instant failover. Azure Front Door is an application delivery network as a service. It does support features like TLS or SSL offloading and web application firewall, DDoS protection, and so on. Similar to Azure Front Door, there is another layer 7 load balancing solution known as Azure Application Gateway, which is a web traffic load balancer that enables you to manage traffic to your web application. Sorry. Like front door, it also includes certain features like SSL offload, web application firewall, and so on. Now, I was mentioning front door is also layer 7 and application gateway is also layer 7 load balancer. The primary difference you should note here is that front door is a global service, whereas application gateway is a regional service. While front door can load balance between your different scale units or stamp units across regions, application gateway allows you to load balance between your virtual machines or containers within a single scale unit. So Azure Application Gateway, as I was saying, works at layer 7, meaning it can actually do URL-based routing. Application Gateway can make routing decisions based on the additional attributes of your HTTP requests as well. For example, the host headers, or as I was mentioning earlier, URI path. In this example that you are seeing here, you can route traffic based on the incoming URL. So if your incoming URL has /images, in the URL, it can route the traffic to the image servers. If it has /video, it can send it to the video servers. I was saying earlier, both front door and application gateway comes with a web application firewall, which provides a centralized protection of your web applications from common exploits and vulnerabilities like SQL injection, cross-site scripting, and so on. Under the hood, web application firewall is a service that is built on top of the rules from the OWASP or Open Web Application Security Project core rule sets. I strongly encourage you to go and check it out. Now, after going through all these different load balancing options, certainly it becomes tricky to decide which service to use when. At a high level, there are few factors that you can consider. For example, your traffic type. Is it going to be a web traffic, or is what kind of traffic it is your application is going to get? Likewise, is it your global service or is it a regional service? What do you want to load balance? Likewise, cost also plays a role in there. If you will head out to the link that I have mentioned down below, Microsoft has done a great job in providing a roadmap or a guidance on how you can choose an appropriate load balancing option for your application. I have found it to be very helpful. Do go ahead and check it out for deciding the right load balancing service for your application. Next is on the list is Azure Content Delivery Network, which is a distributed network of servers that can efficiently deliver web contents to your users. Essentially, CDNs store cached contents on edge servers and point of presence locations that are close to the end users to minimize latency. CDNs is a concept that is just not unique to Azure. CDNs are offered by many other providers outside as well. Basically, it has edge servers which can cache your content and present it to the users based on their nearest location. So for example, if you'll see the diagram that I have depicted in this screen, there is a user Alice who requests the file by using a URL with a special CDN notation, so highlighting it has to go through CDN. Based on that, the DNS routes the request to the best near located edge server. The edge server checks if that content or if that file is already available. It returns it back to Alice. If not, it goes back to the origin. The origin could be a storage account, a web service, or a web server, or an app service, or whatever it could be. The origin returns back the file, which is stored on the edge server, and the edge server returns it back to the user. The advantage you get out of it is the next time any other user requests the same file, and if there is a copy that exists on the edge server, that copy is returned back rather than going back altogether to the origin. Now, you shall note that for any content that sits on that edge server comes with a time to live TTL, which is specified by its HTTP header, and if the TTL is expired, then the edge server removes the content from its storage and goes back to the origin the next time it receives a request from any of the other users. Lastly, before I conclude my presentation, it's important since Azure networking is a core component in your cloud environment. It's important for you to monitor your network traffic and what's going on in your traffic network. It's very essential for security. Azure does offer a couple of different options how you can monitor and diagnose your issues in your network. To start with, the first service is Azure Network Watcher, which enables you to monitor and diagnose health and performance of your data. Using Network Watcher's diagnostics and visualization tools helps you to, for example, capture packets on a virtual machine or validating if an IP flow is allowed or denied and so on. You can identify which packets will be where packets will be routed from a VM and gain insights into an on-ramp network topology. The diagram I'm showing you is a network topology that I have pulled up through Microsoft's website, but essentially if you'll go to Network Watcher, you can get similar topology for your existing network setup. There's another solution known as Network Performance Monitor, which is a cloud-based hybrid network monitoring solution that you can monitor network performance between different points in your networking infrastructure. It does support certain capabilities, including performance monitor, service connectivity monitor, and ExpressRoute monitor. And I believe under Azure Monitor now, which I have not certainly included a slide because the slide deck is slightly old, a month or two old. But I believe there is a new offering under Azure Monitor as well, which you can utilize to monitor your Azure traffic, Azure network traffic. With that, these are some of the resources which I can highly encourage you to go and check it out. Starting with the Azure Architecture Center, where you can get all the networking related reference architectures ranging from hub and spoke to others. And then certainly Microsoft Azure documentation is a source of truth. I will strongly encourage you to go and check out documentation on any service that you intend to utilize for your networking infrastructure in Azure. Go and read out Azure best practices for securing your network. Microsoft Learn is another good source of learning if you are starting with your networking skills in Azure. If you don't have a Pluralsight subscription, Microsoft has a partnership with Pluralsight where they offer 200 plus free courses on Azure. I would strongly encourage you to go and check it out. There are some good courses out there, including some courses on Azure networking. Lastly, Azure Friday is a great show hosted by Scott Henselman. There are some good gems out there. You might have to find out the right episodes, but there are some good episodes on Azure networking services. And as I mentioned earlier, that my session will be helpful to the folks who might be planning for Azure role-based certifications. If you are not aware of them, I would strongly encourage you to go and check out the role-based certifications page where you can get all the details about what is covered in those certifications. Now, with that, I conclude my presentation and I would like to open the floor for any questions that anyone might have.
I have a question. The example that you gave in your demo about one VNet per resource group, is that a common architecture? We're doing a migration project to Azure from a managed data center, and the cloud architect we're working with is recommending everything be on a single VNet, like QA and production, and that doesn't really sound right to me.
So there is no hard and fast rule that you can have only certain number of virtual networks. As I mentioned when I was providing those best practices for designing your virtual networks, the guidance is that it's better to have larger virtual networks. By large, I mean the virtual networks having larger IP address spaces. I can probably pass on the link to you for that. Probably you can go through that. It does details all the details, and I believe it makes sense to me, at least, for having virtual networks with larger IP addresses, and then you can have your resources created under individual subnets if the need is needed. Give me a second, I can send the link on the chat window.
Thanks.
And I will be sharing the slide deck with Bill as well, so that he can share with the community, and all the links.
Yeah, I was going to ask you that if you would send the deck and we'll make it available, or send a link to the deck.
I will send it to you after
Okay.
this presentation.
Sure.
And I
But,
posted the link there on the chat.
Yep. by the way, one thing I wanted to add, and that was a really good, excellent presentation and a good suggestion about VNets, but one of the things to keep in mind is that I wouldn't necessarily want to put production and non-production in the same subscription.
Absolutely.
So that would mean
Good call out, Bill.
because there will be, dev test subscriptions are cheaper. So that would be a reason not to do that.
Absolutely. And as I was mentioning in my slides earlier, that scoping also does matter. And most of these virtual networks are scoped to a subscription. And it, as Bill said, it makes absolute sense to divide your production and non-production workloads into different subscriptions and in their own different virtual networks.
Okay. Another question, just a second one, is about Express Gateway. So we have some carrier traffic, and right now at our data center, they have colo routers. We tried to discuss this with our carrier, and they suggested Express Gateway, but we don't have it like a physical location. So I wasn't really sure where to install this colo router to establish that.
ExpressRoute circuits, you meant?
Maybe I meant ExpressRoute.
Yes, so check out ExpressRoute Direct Service, which doesn't need a middleman in between, and you can connect your networks directly to Microsoft's network. I believe, based on what I understand from your question, ExpressRoute Direct might be the best solution for your use case.
Okay, thanks.
All right. If anyone has any questions later on, feel free to send it my way on my Twitter account or my LinkedIn. I would be more than happy to be connected and respond back to any questions. And with that, I think I'm done. Bill, thank you so much for having me here. I appreciate it.
Oh, thank you. Thank you for doing this. It was I think it was an excellent presentation. Are you going to stick around for a while, or should I stop I guess I'll stop the recording now at this point anyway. Excuse me.
Yeah, feel free, and I can hang on if someone wants